32, duped. Like a Minecraft duped item. We're gonna duplicate line segments. Yeah, nerd reference for you. Hope you have a compass. This is the one that I really strongly prefer, but because that's pointy, I don't give them to you. I give you these. If you want to go get your own, go for it. Now, with this one, we're going to use a compass. There's also our straight edge. It would be a good idea to have a protractor and maybe even some patty paper. This is the same patty paper from lesson 2. Keep the stuff that you've created around, at least until this entire topic is done. Let's get into it. This is directly related to our learning goal from the previous video on using construction tools to duplicate. We're going to duplicate a line segment, but we will also talk about how that notation or that help will eventually lead us to do the work for duplicating an angle. Consider circle A. Pretty nice circle. Construct BC congruent to AB in circle A so that point C lies on circle A. I mean, I'm only like playing it up for you dramatically. I know exactly what to do, but when you read something like that, like, do you follow along? Like, does it make sense, right? So, construct BC. I don't see no BC. We're gonna have to make it. It has to be congruent to AB. So that's a word that I want to pay attention to. The congruent means the same size, and a compass is the geometry way of preserving size. So I'm going to make the compass. I'm going to slide the span of the compass, pinch it, and then slide it over. See that hole right there? It's exactly over. Move it better. It's exactly like centered on B, and then the center of the circle, like it's got to be all lined up, is exactly over A. Make a minor adjustment if you need to, okay? So that's the setup. We want to set up the compass so that the span, like how spread out the compass is exactly that distance inside hole. Now, to duplicate a line segment and move it on the circle, we're going to flip the compass around. I'm gonna need some space here. And then instead of centering the compass on A, don't change the size at all. We're gonna center the compass on B. Pencil goes in. Maybe find one that's got a good point to it. And before I even draw, I already know that I want a part of a circle, not a full circle. So there, kind of like fudge a little bit. And that point right there is point C. It's exactly the same distance, label. It's exactly the same distance. See, I can measure it with centimeters. I get approximately 17 centimeters. So if I measure this radius, that's approximately 17 centimeters. And if I measure, actually, check this out. If I measure BC, gosh, that's also 17 centimeters. So construct BC. I need to draw BC. There it is. From point B to point C, there's the chord. It's called a chord because it goes across the circle. And it lies on the circle. Yeah, check. There we go. Okay, connect point AC. So ruler, straight edge, connecting point AC. There it is. Check. What do you know about the length of AC? You know, I just measured it. I just measured AC. I measured that AC as a measurement is exactly equal to the measure of AB, which is equal to the measure of BC, which is about 17 millimeters. That's what I confirmed. So then, wait. All three sides of the triangle are the same length. That must mean triangle ABC is an equilateral triangle. Because the definition of equilateral is actually in the word equa, meaning equal, and then lateral, which means side. Why am I using this one? Yellow and green. You already let me know that yellow and green look the same in a video, so let's make sure they're split. ABC is an equilateral triangle. That means the sides are the same length. What do you know about the angle measures of triangle ABC? Let's conjecture here and think about what you should already know from a previous math class or life. If all three sides are the same, all three angles are the same, all three angles are congruent. Apparently the bell means that's my time. Thank you for watching this video. Let's keep rolling with lesson 3. Click the next video, and we'll see you on the math trail. Thanks, bye.